Let's look at exactly what all this emphasis on color space is about. Now, what I'm going to do is display the colors in a specific image into a 3D modeler and compare it to the various color spaces we've discussed. Now, before we load the image into the modeler, let's look at the image. Now, this obviously is a heavily leaning warm image with reds and oranges, yellows, and dark blues and purples. Now, we want all the tiny variations in not only the color, but in the tonal gradations to help our colors look more natural. Now, let's load the image into the modeler, and this is what it looks like. Now, all of the colors in the image we just saw are contained in this 3D model. And as we look at it from the top, we can see a broad range of things like greens and purples, blues, reds, green. All of those colors that we saw in the image are reflected in the 3D model of the image. And as we look at it from the side, we can see that the image tends to be a bit dark, as this area right here represents the brightest areas of the image. And of course, as we go down, these are the darkest areas of the image. And the image has a general darker tone to it. And that would be expected based on the kind of image that we have. Let's now put some color spaces over it and see exactly how that's going to look. And we're going to start with the smaller of the three, and that's sRGB. And I'll adjust the opacity to 50% so that you can see how the image and the color space interact. And as we can see, all of these colors right here are not contained in the sRGB color space. And as we wheel around, we can see other colors in the reds and the darks and the purples that are, again, not contained in the sRGB color space. So what that means is that when you process the image out of its raw state and you save it in the sRGB color space, you're going to throw away all the colors that are outside this image. And in this kind of image, that's a great deal of digital information you're just tossing aside. All right, let's now look at the next largest color space, and that will be Adobe RGB, and things do look a lot better. But that's only better because, as we see, there are still colors, less of them, but there are still colors that do not make it when we convert into the Adobe RGB color space. These colors are thrown away permanently, never to be seen again. And there's still some colors like that in the pinks and reds that, once again, have been thrown out if you had done your processing in Adobe RGB. Now let's look at the solution to all of this conundrum, and that is ProPhoto. And again, we're going to adjust the opacity, and we're going to notice here that there are no colors that lie outside the ProPhoto color space, meaning that all of the colors that this image contains and therefore came in off the sensor are contained in the image and were used when we developed our final file that the print was made from. Now let's take a look at another image. It's going to give us another set of considerations in this discussion of color space. And we'll take off the image we were looking at. And now, before I bring it into the modeler, let's look at the image itself. And this is an image taken in Yosemite National Park in Yosemite Valley. We have El Capitan in the background, and of course the Merced River in the foreground with the log. Now, obviously, the overall tone on this image is green. There's a lot of green. And you'll notice a lot of subtle variation in the tones of green, and that's what we want. And when you throw digital information away, you remove some of that subtlety in those tonal gradations within the green range that we always want to keep. So now let's bring it into the modeler, and we'll go ahead and click on this, and we will remove the overlay of sRGB. But let's look at the image, and as we can predict, there's a lot of green. Here's all those green colors that were in the image. But what was surprising is that we had a lot of purple, pink, magenta, orange, and if we look at it from the side, these are in the very dark areas of the image. And there's a flatness in the colors contained in this image, and I'll show that to you in just a minute. But we can see that there's a lot of color in this image. Let's now look at the sRGB color space overlaid on the image. And as we would expect, there's a lot of green that would not have been in the image had it been converted into sRGB. Same thing occurs Over here in these pinks, these magentas and orange and reds over here is a lot of that color information that would not have gone into the image at sRGB. Let's now look at the overlay for Adobe RGB, which improves things somewhat, especially in the green sections of the image, although there is one particular color that did not make it into the Adobe RGB color space. Most everything is in there. Where it is lacking, however, is being able to contain those images over here, where again the magentas, the purples, the blues, and a little bit of that warm color right here did not make it into the image had it been converted again as Adobe RGB. Now let's look at the ProPhoto RGB, and as we would expect, all of the colors that are in that image are contained in ProPhoto RGB. After all, the color space that's assigned to this image as we brought it into the modeler is ProPhoto RGB. But I want to show you a surprise. Right here, now although they are contained within the ProPhoto color space, the flat indication on these colors shows us that very possibly there were colors that came in off that sensor that were not even contained in the ProPhoto RGB color space. So that's why it's important to go ProPhoto whenever you're going to import an image as a raw conversion, again, as 16-bit TIFF in ProPhoto. This is why. So by now you should have a full understanding of what we're talking about when we discuss the color spaces within an image, and I hope this will guide you when you engage in processing your images.